medcram.com.
Welcome to another MedCram COVID-19 update. You can see the numbers here. They are starting to exceed that of mainland China when we look globally. What I wanted to get to today is something that a lot of you have commented on, and that is the receptor for the SARS CoV2 virus that causes COVID-19, and that is the ACE2 receptor. The ACE2 receptor is how the virus gets into the cell. It's the doorway, and it's more than just a doorway. And today we're going to be talking about exactly what the ACE2 receptor is and what it's involved in and why that matters. I've been wanting to do this for a long time, but the more I looked into it, the more complicated and interesting at the same time that it was. So I wanted to do the research first and then tell you where we are right now. This has reached a head because there are a number of people out there that are actually taking different sides on this issue of the receptor. So what it boils down to basically is, as we've talked before, outside of the cell or on the surface of the cell, there is a receptor for the SARS CoV2 virus, which is the thing that causes COVID-19, which is the coronavirus. And so here we have the virus, and it's got these projections that make it look like rays of the sun. That's why it's called the coronavirus. This is SARS CoV2. This is 2019 coronavirus. Here is the S protein that we've talked about. And the receptor for this is on the surface of the cell, specifically cells that are found in the lung, the type 2 pneumocyte it's known as, and also in the GI tract. And this receptor is known as ACE2. And that's really important for you to understand, ACE2. This is where the S protein docks. And then there's another protein called a serine protease, which is also here in the membrane, which helps to internalize this virus into the cell, and it allows the messenger RNA, which is in here, to come in and infect the cell. The key here, though, is this protein that is on the side of the cell is ACE2, and it's exactly the same protein that was the receptor for the SARS CoV virus that was back in 2002. So the question is, why is this such a problem? Well, there is some animal data that angiotensin receptor blockers, which is a very common type of high blood pressure medication, and ACE inhibitors, which is another common type of blood pressure medications, can increase the concentration of these ACE2 receptors on the surface of the cell. So how do you know if you're on an ARB or an ACE inhibitor? Typically, ARBs end in TAN. So you might see this as losartan or irbesartan or candesartan. These are all TANs. They are angiotensin receptor blockers. We're going to talk more about what they do. So if it's true that they could increase ACE2 levels, it seems like it would be common sense that if you have more ACE2 receptors on the surface of your cell, now you've got more entry points for the virus to infect your cell. ACE inhibitors, they typically end in pril, so captopril and nalopril, and the list goes on. Those can also increase potentially your ACE2 receptors. And so what do we do with patients who are on ARBs and ACE inhibitors? Well, it seems as though people have a higher mortality who have a history of hypertension. And so this has led to a number of articles and a lot of social media to talk about, well, should we get off of our medications that we're taking for high blood pressure? So here is an article that was sent to the Lancet, was published on March 11th, 2020. And the question is, are patients with hypertension and diabetes mellitus at risk for COVID-19 infection? And they talk about the incidence of cardiovascular diseases. They talk about the SARS CoV virus and SARS CoV2 and the ACE2 protein, which is the receptor for this. And they talk about how ACE inhibitors and ARBs increase ACE expression. The increased expression of ACE2 would facilitate infection with COVID-19. We therefore hypothesize that diabetes and hypertension treatment with ACE2 stimulating drugs increases the risk of developing severe and fatal COVID-19. Now, this is only a hypothesis. They say here, if this hypothesis were to be confirmed, it would lead to a conflict regarding the treatment because ACE2 reduces inflammation and has been suggested as a potential new therapy for inflammatory lung diseases, cancer, diabetes, and hypertension. A further aspect that should be investigated is the genetic predisposition for an increased risk of SARS CoV2 infection, which might have to do with ACE2 polymorphisms, they say. And here, finally, they say, we suggest that patients with cardiac diseases, hypertension, or diabetes who are treated with ACE2 increasing drugs are at higher risk for severe COVID-19 infection and therefore should be monitored for ACE2 modulating medications such as ACE inhibitors or ARBs. We did not find any evidence to suggest that antihypertensive calcium channel blockers increase ACE2 expression or activity. Therefore, these could be suitable alternative treatment in these patients. Here we have an article, a correspondence to a very major journal, which is raising an alarm on millions of patients who are on these medications and saying that they hypothesize that the patient could be at risk. So obviously this has raised quite a stir. And the question is there any actual truth to this? So let's look and see what the response has been. Well, here is the response from the European Society of Cardiology. They say here, because of social media-related amplification, these patients taking their high blood pressure medications have become increasingly concerned and in some cases stopped taking their ACE or ARB medications. This is what the official response is from the European Society for Cardiology. The speculation about the safety of ACE inhibitors or ARB treatment in relation to COVID-19 does not have a sound scientific basis or evidence to support it. Indeed, there is evidence from studies in animals suggesting that these medications might be rather protective against serious lung complications in patients with COVID-19 infection. But to date, there is no data in humans. The Council on Hypertension for the European Society of Cardiology wished to highlight the lack of any evidence supporting harmful effective ACE inhibitors and ARB in the context of pandemic COVID-19 outbreak. They strongly recommend that physicians and patients should continue treatment with their usual antihypertensive therapy because there is no clinical or scientific evidence to suggest that treatment with ACE inhibitors or ARBs should be discontinued because of the COVID-19 infection. So what is it? Which one of these is correct? To delve into the intricacies of that, we're going to go into some molecular biology. At some point, we'll get a little complicated, but not too. So bear with me as we go through a detailed instruction on exactly what is going on here with the SARS CoV2 virus and the renin-angiotensin system. To understand this, you first start off with a hormone called angiotensinogen. And that is converted into angiotensin 1, which we'll abbreviate AT1. And that is done through an enzyme called renin that is produced by the kidney. Angiotensin 1 is then converted into angiotensin 2, and that is done in the lung by an enzyme called ACE. Now, ACE is in the lung. It does convert angiotensin 1 to angiotensin 2, and we can inhibit ACE by giving someone an ACE inhibitor. And these are the medication that end in prils. So captopril and lisinopril, etc., etc. So angiotensin 2 is a powerful vasoconstrictor. It also stimulates the adrenal gland to make aldosterone, which has the action of lowering potassium and increasing sodium concentration, and therefore increasing blood pressure. Angiotensin 2 is a major dividing point because there's two types of states that one can have in the body. So we'll call this the low state, and we'll call this the high state. On the cell membrane is a component of proteins that are sitting out on top of the cell membrane. And one of those is ACE2. And when there is not a lot of angiotensin 2 around, it is proposed angiotensin receptor 1, or ATR1, sits in the catalytic site of ACE2. Now, as it turns out, angiotensin 2 will be converted by ACE2 into angiotensin 1 7. And it's very important for you to understand angiotensin 1,7 because angiotensin 1,7 causes vasodilation and decreases inflammation. That's a good thing. It's also possible that you could put and have an angiotensin receptor blocker that would block this, and that is an ARB. So we've talked about angiotensin receptor blockers, and we've talked about ACE inhibitors. If you have high angiotensin 2, this is the situation that you get. You still have ACE2, but the high levels of angiotensin 2 cause the angiotensin receptor to come off of ACE2. And when that happens, when angiotensin 2 interacts with angiotensin receptor 1, the result of that is vasoconstriction, increased blood pressure, increased vascular permeability, pulmonary edema, and presumably ARDS. Furthermore, when there's high angiotensin 2, the hypothesis is that this opening in ACE2 allows for the coronavirus with its S protein to bind to ACE2. This binding here also requires something called a serine protease, known as TMPRSS2. Now that can be inhibited with something called camostat mesylate, and that is undergoing trials right now. Interestingly, when you have high levels of AT2, this entire complex can get degraded into lysosomes. So let's review quickly. We've got angiotensinogen being converted to angiotensin 1 by renin. Angiotensin 1 is converted to angiotensin 2 by an ACE enzyme. ACE inhibitors can prevent that from happening. If you have too much of angiotensin 2, then what can happen is this angiotensin receptor blocker dissociates with ACE2 and it gets activated to cause vasoconstriction, increased blood pressure, permeability, pulmonary edema, and ARDS. That's exactly what we don't like to see in these situations in viral pneumonia. However, if there are low levels of angiotensin 2, then what we see is that it gets metabolized by ACE2, and that gets converted into a vasodilator called angiotensin 1,7. Also, it looks as though ARBs, or angiotensin receptor blockers, can somehow keep this complex together and keep that catalytic site blocked by the resident ATR, or angiotensin receptor. And that can happen with angiotensin receptor blockers. If it's high, however, this dissociation occurs, allowing the virus to potentially bind, according to the hypothesis, and that causes degradation. So what do we see in people who have no ACE? If we take away all of their ACE2, as we're shown here, what happens? Well, they've actually done this in mice. They're able to breed mice where they delete the gene responsible for making ACE2. They're called knockouts. Double knockouts mean they take it both on the mother's side and the father's side, so when the mouse is born, it has no ACE2 whatsoever. They've shown that these mice have a resistance to being infected with the virus because there's no receptor. But at the same time, what they see in these knockout mice is that they have worse outcomes in viral pneumonia, they have decreased cardiac contractility, and they have increased levels of angiotensin 2, which makes sense because it's ACE2 which breaks down angiotensin 2 when there is a low amount of it. So these are in what we call ACE2 knockout mice. And these are exactly the things that we're seeing in patients who are infected with the coronavirus. What they saw in a mouse model of SARS CoV from 2002 was that there were decreased levels of ACE2 in these viral models, and they had normal ACE levels, but there was less ACE2 levels. They also saw increased levels of angiotensin 2. And when they gave these mouse models ARB and they gave them ACE inhibitors, this actually improved the outcomes. And I'll show you the links to those studies in the description below. In a respiratory syncytial virus case, they actually took recombinant ACE2 and gave it to these mouse models, and they found that it improved outcomes. So you can see, according to the animal hypothesis, that if you added an ACE inhibitor, it would block this ACE enzyme, making sure that this angiotensin II was on the low side. But what we may be seeing is that these angiotensin levels are actually on the high side. And you would predict that if angiotensin II levels were on the high side, you would expect there would be aldosterone and low potassium and high blood pressure. And that's exactly what they saw in very, very sick COVID-19 patients, is that they were hypokalemic, which means low potassium. And the most critical of these had higher blood pressure before they crashed. You can also see here how keeping somebody on a angiotensin receptor blocker, according to this hypothesis, may improve this kind of a situation, leading to vasodilation and anti-inflammation. I want to emphasize that while we have good data in mice, when we look at humans, we don't see these kinds of things happening, at least in the plasma, in free-floating ACE. We don't know what's going on at the tissue level, so it still may be happening. And so the thing I want to stress here is that this is all a hypothesis based on piecing together studies over the last 20 years, that they feel that this may be what's happening. And if you're interested in this kind of research, I'm going to put a bunch of links in the description below that link to the papers that talk about this. But suffice to say that at this point, to go out and say that we should be stopping people on their ACE inhibitors and stopping people on their ARBs, in my humble expert opinion, as much as you want to consider me an expert on this, I would say that the jury is out, and I believe I would come down on the side of the statement from the European Society for Cardiology and saying, we really don't know at this point, and we have some animal studies which actually show that they may be protective in this case. There's been a number of reports on the deaths in COVID-19 that their ejection fractions or their cardiac contractility have been fine when they come into the hospital, but over a couple of days of either viral myocarditis or because of this situation that we're seeing here, that their contractility has dropped significantly, as we would expect when ACE2 levels go down. So this is something that needs to be addressed. And we don't know exactly what is going to happen until we have those studies. The good news is, according to what I have seen in the last couple of days, there is research looking into starting patients on angiotensin receptor blockers, or ARBs. So that was a very long explanation over something that has come up very recently. I think we should continue to delve into this receptor issue, especially when it comes to talking about vaccines, because ACE2 is going to play an extremely important role in the future of treatment of COVID-19. Thank you for joining us.